Silicon is the 14th element on the periodic table with the atomic number 14. It is a metalloid and belongs to group 14, sometimes called the carbon group. Silicon is one of the most abundant elements in the Earth's crust and plays a vital role in both nature and modern technology. Like phosphorus, pure silicon does not occur freely in nature. It is usually found in compounds, especially as silicon dioxide and silicates in rocks and sand. Silicon was first identified in 1787 by the French chemist Antoine Lavoisier, who suspected it was a distinct element, but it wasn't isolated in pure form until 1823 by Swedish chemist Jöns Jacob Berzelius. Berzelius obtained silicon by heating potassium with silicon tetrafluoride. This marked the beginning of silicon's journey from an unknown element to the foundation of today's digital world. Silicon is found primarily in the Earth's crust, making up about 27% by weight, second only to oxygen. It occurs mostly in the form of quartz, a hard crystalline mineral composed of silicon and oxygen. Silicon is also found in various types of silicate minerals, which are the main components of most rocks. Large amounts of quartz sand are mined to produce high-purity silicon used in electronics, glassmaking, and other industries. Silicon exists in several different forms, or allotropes, though the most familiar is the crystalline form used in semiconductors. Pure crystalline silicon has a shiny, metallic gray appearance and is hard and brittle. Amorphous silicon, which lacks a long-range crystal structure, is used in thin-film solar cells and certain types of electronics. Another lesser-known form is porous silicon, which has a sponge-like structure and is being explored for medical and optical applications. The most common industrial use of silicon is in the production of computer chips and electronic devices. Silicon's ability to act as a semiconductor, conducting electricity under certain conditions, makes it the foundation of modern electronics. Silicon wafers serve as the base for integrated circuits, which power everything from smartphones and computers to medical equipment and satellites. To produce electronic-grade silicon, quartz is first refined into metallurgical-grade silicon by heating it with carbon in electric furnaces. This raw silicon is then further purified using processes like the Siemens method or zone refining to reach the extremely high purity needed for semiconductors, often 99.9999999% pure. Silicon wafers are sliced from large crystals and polished for use in microchips. In addition to electronics, silicon is crucial in making glass, ceramics, cement, and silicones. Silicon dioxide, or silica, is the main ingredient in most types of glass. When melted with other substances like soda and lime, it forms glass used in windows, containers, and fiber optics. Silicates are used in building materials like concrete and bricks. Silicones, silicon-based polymers, are flexible, heat-resistant materials used in lubricants, sealants, medical implants, and cookware. Silicon is not essential for human life in the same way phosphorus is, but it does have some biological roles. In humans and animals, silicon helps with the formation of connective tissue, bone, skin, and cartilage. It is found in small amounts in foods like whole grains, fruits, and vegetables. Some evidence suggests it may support bone health and skin elasticity, though more research is needed to confirm its full role in the body. In plants, silicon plays a more active role. It helps strengthen cell walls, making plants more resistant to pests, disease, and drought. Rice, in particular, takes up a large amount of silicon from the soil, and silicon-rich soils often lead to healthier crops. Because of this, silicon-based fertilizers are used in some types of farming to boost yield and crop resilience. Environmental concerns around silicon production mostly involve the energy required to purify it for high-tech uses. Refining silicon into its purest form uses a lot of electricity and generates waste materials, including carbon dioxide and other emissions. Manufacturers are working to make these processes more efficient and less harmful to the environment. Recycling is also becoming more important in the silicon industry. As demand for electronics grows, efforts to recycle silicon from used devices and manufacturing waste are increasing. Recycled silicon can be used in lower-grade applications, helping to reduce raw material needs and environmental impact. Silicon plays a central role in solar energy. Crystalline silicon is the main material used in solar panels. These panels convert sunlight into electricity through the photovoltaic effect. Solar energy has become one of the fastest-growing renewable energy sources in the world, and advances in silicon technology continue to improve the efficiency and lower the cost of solar power systems. In the field of nanotechnology, silicon is being explored for even more advanced applications. Silicon nanowires, for example, are tiny structures that can conduct electricity and are being studied for use in future electronics, batteries, and sensors. Silicon photonics, a technology that uses silicon to manipulate light instead of electricity, holds promise for faster, more energy-efficient communication systems. Silicon also has medical and cosmetic uses. Silicones made from silicon are widely used in prosthetics, implants, and contact lenses due to their flexibility and compatibility with the human body. In cosmetics, silicone compounds give products a smooth texture and help moisturize and protect the skin. Because silicon is chemically stable and forms strong bonds with oxygen, it is very durable and resistant to weathering. This makes it a long-lasting material in construction and technology. However, the stability of silicon compounds also means they can be difficult to break down in the environment, so careful disposal of silicon-based products is important to avoid pollution. Safety-wise, silicon itself is not considered hazardous. However, inhaling fine silica dust, especially crystalline silica, can cause lung diseases like silicosis. Workers in mining, construction, and manufacturing industries must take precautions to avoid exposure. Regulations and protective equipment help reduce health risks associated with silicon processing. In summary, silicon is a vital element in both the natural world and modern technology. It is abundant in the Earth's crust and forms the backbone of everything from rocks and glass to microchips and solar panels. While not essential in the same way phosphorus is to life, silicon still plays useful roles in biology, especially for plants. Its impact on electronics, energy, and industry is massive, making it a cornerstone of our technological society. As innovation continues, silicon remains at the heart of efforts to build faster computers, harness clean energy, and develop smart materials for the future. Sustainable production, recycling, and safe handling will be important to ensure that silicon continues to support progress without harming the environment or human health.